Hi everyone, this is Mr. Hall and this is a video about calculating moles. I've already made one video about moles, number of molecules and Avogadro's constant. This is a continuation of that where I talk about how to calculate moles using mass and MR data, and I'll also talk about two-step problems. So the objectives for today's video are as follows. It's to calculate the number of moles and mass for substances using MR data, and we'll also go through how to complete two-step problems using Avogadro's constant. So first off, I just want to go back to what we learned in a previous video and what you've hopefully learned in previous learning, which is that 1 mole of any element is the relative atomic mass in grams. Okay, so here I've got oxygen where it's got an atomic number of 8 and a mass number of 16. So if I was to say what is the mass number for 1 mole of O2, well, you know that the mass of oxygen is 16. So to work out the MR for O2, you'd simply just get 2 lots of 16, which would give you 32. So to work out the mass of 1 mole of O2 would be exactly the same as the MR, because the MR is the same as 1 mole. So that would be 32, okay, and that is equal to 1 mole. Now, that'd be 32 grams, by the way. Now, if I was asked about 0.5 moles, if we have a look at 0.5 moles, which is half of 1, well, if I have 0.5 moles, it would be half of 32, so that would be 16 grams. Would equal to 0.5 mole. And then if I've got 0.1 mole, which is a tenth of 1, then it would be a tenth of 32, which would be 3.2 grams, which would equal 0.1, which how far I've got here to write. There we go, 0.1 mole. So you can see that basically all I'm doing is, in order to get to the number I'm looking for, I'm basically multiplying my MR by the moles, and that effectively gives you the mass. Now this quite nicely leads us onto the equation that links all three, and we can put it as an equation triangle. So the equation triangle looks as follows. So at the top you've got your mass, at the bottom left you've got your moles, bottom right you've got your MR, your RAM, as so. And then from these, or from this equation triangle, you can work out your three equations. Now what we've just been using is mass equals moles multiplied by MR, or RAM, relative molecular mass, whichever one you want to use. Now, if I want to work out moles, because sometimes you need to find that out, I need to do mass, which is at the top here, divided by my MR. Okay? Now, sometimes, and this is very rare, you might be asked to work out the MR of like an unknown element or an unknown compound. You might be asked that if it's a really hard question. And it's just using this equation triangle again, so it's going to be mass divided by moles. I must stress that that will be rare that you'll be asked that, but it could happen for a tough paper. So let's go through some examples. So if I'm trying to work out mass, let's think about it. I've got 40 grams of NaOH. Now the formula mass, or the MR, however you want to call it, it's 40. Therefore, if you have 40 grams of sodium hydroxide, or NaOH, you have 1 mole. Therefore, if my formula mass is 40, that means 1 mole is 40 grams. So if I've got 0.5 moles, it would be, if you remember the equation, mass equals moles times MR. If I've got 0.5, it's going to be 0.5 multiplied by 40, which will equal 20 grams. And if I have 0.25 moles, it'd be 0.25 multiplied by 40, which equals 10 grams, and so on. Okay, so that's how you do those calculations. The one thing I do have to stress at this point is always show your working. If you don't show your working and you're using wrong numbers, you get the whole thing wrong, you won't get any marks. However, if you do show your working, you might pick up a mark or two, so definitely show it. If we try a different problem, let's say, what is the mass of 0.25 moles of nitrogen, or N2, the most abundant gas in our atmosphere? So I'm looking for mass. I've got moles. So the first thing I always do is I write out what the equation is. It's remarkable how many students don't do this, but the more you do it, the better. So mass equals, I look at my equation triangle, moles times MR, all right? Now I know my moles, it's 0.25. I have to work out my MR for nitrogen. Now, if you look at the periodic table, nitrogen has a mass of 14. So therefore, it's going to be 14 times 2, which equals 28. Therefore, to work out the mass, it's 0.25 multiplied by 28, which equals, I think, 7 grams. Okay, and that's how you do it. Notice I've shown my full working. I've shown the working for the MR. You have to show the detail for all those steps. Okay, so let's try another problem. What's the mass of 0.16 moles of CaCO3? Again, I write out the equation of what I'm going to use. It's mass equal moles multiplied by MR. Now the MR, I have to, it's still a bit more complicated here, so it's going to equal Ca, which I think is 40, plus carbon, which is 12, plus O3, which is 3 lots of O, which is 16, which I think altogether leads to 100. Okay. So to work out the mass, it's going to be 0.16 multiplied by 100, which gives me 16 grams. All right, so that's how you do those problems. So relatively straightforward. Now for moles, let's have a think about this. If I have 1 mole of lithium hydroxide, that will basically mean it will be the same as the MR, or the formula mass for that substance. Now the formula mass is 24 if you calculate it, therefore 1 mole is going to be the same as 24, which is the MR in grams. So if we kind of write this out, formula mass is 24. 24 grams is 1 mole. So if I have 12 grams, that's 0.5 mole. If I have 6 grams, which is sort of going half again, that's 0.25 mole, and so on. Now you can see carefully that what I've done is, in order to work out the mole, I've simply divided the mass by the MR, and I'm using the equation from the equation triangle there. Because if you look, for example, at this last example here, the mass is 6 grams. I've divided it by the MR, which is 24, and that gave me 0.25. And you can use that for any mole, any mass, particularly when you've got more complicated numbers and more sort of precise decimals. So let's try a couple of examples. If I have 11 grams of N2O, how many moles do I have? Now the first thing I do is I use the equation triangle. So I've got moles equals mass divided by MR. Now let's work out the MR. Now I've got N2O. So N, which is nitrogen, has a AR rather of 14. So it's going to be 14 times 2. And I have to add the AR for oxygen, which is 16. Therefore, it's going to be 28 plus 16, which is, I think, 44. So to work out the moles, I've got the mass, which is 11. I divide that by 44, and I think that equals 0.25. I want to just double check this so I don't make any silly blunders on the video. So 11 over 44, yeah, 0.25. So I have 0.25 moles. Okay? And that's how you do it. Now, you might sometimes get 2-step problems, and these are particularly nasty. So, for example, you might be asked, how many grams would 3.91 times 10 to the 25 molecules of N2O weigh? Now, some of you might get really stuck by this thing, or where do I go? Now, to solve these problems, you have to remember that if you look at both equation triangles, they both have moles. Now, ultimately, for this question, you are starting with this information. And you want to end up with this information. So they're on different equation triangles. So it's a 2-step problem. Step number 1, you have to work out the moles by using the number of atoms or molecules which you're given and Avogadro's number, which is 6.022 times 10 to the 23. Remember, that's a constant which you'll always get. And then for the second step, you have to work out the mass using the moles which you calculate from the previous step, and you have to use the MR data, or the RAM, which you know you can get because it's basically the MR of N2O. So it's a tricky problem, but more than sort of solvable as long as you take those relevant steps. So let's have a go at this. So this is the problem I just showed you before. So step number 1, again, this is one you definitely want to show your full working for. So you want to do 3.91 times 10 to the 25 divided by 6.022 times 10 to the 23. Okay, that's step number 1. All right, now that gives you the number of moles. I'm not going to kind of put it in my calculator at the moment, but I'm just going to call it M. All right, so that'll give you the moles, which we'll just call M for now. Now for step 2, you have to work out the mass, if you remember. Now the mass is equal to the moles multiplied by the MR. Now the MR for N2O, I think we calculated this before, is going to be 14 plus 14 plus 16. So that's 28, 38, 44. So it's going to equal the moles from earlier, which is M, multiplied by 44, and that will give you whatever the mass is going to be in grams, okay? So that's how you do it, okay? The tricky bit is just noting that you have to use both equation triangles. Let's try a second problem. How many molecules would be in 0.83 of CuSO4? Now, molecule is a bit lax here, really, because it's ionic, so it'd be formula units, to be perfectly honest, but I won't go into detail on that. So I've been given the number of something, okay, which is, well, I'm looking to find that out, but I've been given the mass, which is that. So again, I have to work out moles first. This will be my first step. This will be my second step. So I'm going the other way now. So I need to work out moles. This is for number one. So moles equals mass divided by the MR. Now the mass here is 0.83 and the MR is whatever copper sulfate is, which is quite a big one actually. So I think the MR is copper, which is 64 plus 32 plus 4 lots of 16, which is basically 64. So that'll be 54. So that'll be 160. Okay, so it'll be 0.83 divided by 160, and that will give you quite a long number here. It's 0.005187.3. Okay, that's the number of moles. Now for step 2, I now need to work out the number of molecules. So I need to work the top bit out here. So that's moles times Avogadros. So I'm just going to write number of molecules equals moles multiplied by Avogadros, which I'm just going to call that. And that equals this previous number. So this now is used here. So it's 0.005187.3, and I times by Avogadro's constant, which is 6.022 times 10 to the 23, which will give you a very large number. Okay, so that's how you do these problems. They're tricky and they're definitely worth practicing just in case they come up as a nasty sort of end of paper question. And that's it. So I hope that's been helpful, and best of luck with your mole calculations.